Alright, in this video we're going to go through the solutions to the first exam. I know there are two versions of this, but we're going to go through just one of the versions since they're very similar. But I will post solutions to both of these on Blackboard as PDFs, so you can go through those solutions and watch the video if you want for the idea for each of those problems. So the first problem, I'm asking for the derivative of this function, so g prime x. So then this is fundamental theorem of calculus. So if this was just an x, then g prime of x would be x squared minus 1 over x squared plus 1, just applying the fundamental theorem of calculus. But it's not, it's a function of x. So remember, that just means we need chain rule. So then we've got g prime of x is, we take the derivative of this pretending it's just x, which would be plug in what we have here into our u. So then we've got sine x squared minus 1 over sine x squared plus 1. And then we multiply by the derivative of the inside. The derivative of sine is cosine. And there you go. Let me make a note. Okay. And that's it. So, next problem. Here I'm looking at this problem and saying, okay, I've got a lot of pieces to it, but I definitely have a function inside another. And that's happening right here at the top. So then I go through my steps, right? Step 1, is this a Calc 1 integral? No. So then I go to u sub. Well, I do see a function inside another, and even if I don't see its derivative right away, I could just try u equals square root x. So just give it a shot. Du is equal, and remember this is x to the 1/2, so the derivative of that is 1/2 x to the negative 1/2 dx, which is 1/2 1 over the square root of x. Then I go back to my integral and I say, okay, I actually do have that in there. So I don't have the 1/2, so I'm going to take the 1/2 and move it over to the other side. That'll give me 2 du equals 1 over square root of x dx. I plug back into my integral, so all together now gives me sine of u times 2 du. I can take the 2 out, sine u du, and then we just have to do the antiderivative of sine. So remember, the derivative of cosine is negative sine, so then the antiderivative of this will be negative cosine plus c, and then remember we want to go back to x's, so this is negative 2 cosine square root x plus c. Alright, next problem. So we look at this and immediately I see multiplication of two functions, no clear function inside another, no clear u and its derivative du. So I try integration by parts. So that means u equals, and then I need dv equals. Okay, so remember for u, we try to look, is there a function whose derivative becomes simpler, right? And the problem is, yes, x to the 6th then becomes 6x to the 5th. But if we remember our limit, we remember, okay, I should pick log first for u. So I'm going to pick natural log of x here. And then remember, dv is just everything else. So that means that must be x to the 6th dx. So again, at this point, it's not that you know this is going to work necessarily, but you can try it, see what happens when you set up into the function, or into the equation, uv minus the integral of v du, and then we could just see what's going to happen. So let's do our du. It's 1 over x dx. Our v is x to the 7th over 7. Okay, so plug into the formula. So that's uv, natural log of x, minus the integral of v du. So that's 1 over x, x to the 7th over 7, dx. And then we also have our bounds still, 1 to 2, and we'll plug in 1 to 2. Okay, so we could just focus on this integral. So I'm going to go to another page to do that, just to save a little space. Okay, so then our integral over here was the integral from 1 to 2, 1 over x times x to the 7th over 7 dx. Okay, well, what I can do first off is I see an x and I see an x. So I know that I have 7 copies of x on top, 1 on bottom, so that's really 6. So this is really 1 over 7 x to the 6th dx. I can move the 1 over 7th out, and I'm left with this, and then it's just the rule I know, add 1, divide, times 1 over 7 x to the 7th from 1 to 2. Okay, so then that becomes 1 over 49, and then x to the 7th from 1 to 2. So I'm going to take this and put it back into my solutions. So let's go back over here. So then that ended up being, let's write the whole thing out again. I'm actually going to evaluate all of this at the same time now. This was x to the 7th over 49, and all of this can be evaluated from 1 to 2. Okay, so we can do that here. So we plug 2 in first. So that would be 2, oops, that's a z. That would be 2 to the 7th over 7, natural log of 2, minus 2 to the 7th over 49. Okay, all of that now subtract. I'm going to plug 1 into the first one, but what you'll see happens is natural log of 1 is 0, so that's just 0, minus 1 over 49. Okay, so we can kind of try to just play around with this, right, and see what's going to happen, but just leaving it unsimplified is perfectly fine as well. So this would be 2 to the 7th over 7. You can factor that out if you want, leaving natural log of 2 minus 1 over 7 minus 1 over 49. So you can play around with this and simplify, put it into calculator, whatever you want to do, but an answer like that's perfectly fine as well. Okay, next one. So this problem, I see powers of trig. So then I think to myself, well, this must be one of the ones where I had to peel a power off, I had to take one trig function, turn it into another one. So the only one I said you had to have memorized was the form of this one, which meant sine squared is 1 minus cos squared, or the other way around, cos squared is 1 minus sine squared. Okay, so then in order to use that, I have to have even powers, which means I should peel off one of these sines. So let's do that. So sine x, sine squared x, cos to the 4th, x dx. Okay, so then this lone sine, to me, screams, okay, that's got to be part of my du. If that's part of my du, then that means I need to pick u equals cosine x. Alright, so let's just try. Du is negative sine x dx. Move the negative over. And then we can do our substitution. So then substituting this in would give me the integral. So remember, sine x dx becomes negative du. Okay. And then what I'm going to do is just look through and say, okay, well, the cos to the 4th can be u to the 4th, so that's not bad. Okay. But the problem here is I have sine squared. That is not in terms of cosine. But remember, this right here is the same thing as 1 minus cosine squared x. Well, 1 minus cosine squared x can become 1 minus u squared. Take the negative out. 1 minus u squared times u to the 4th du. And this is just a polynomial now. So if I multiply the polynomial out, let's head over here. I'm going to get negative u to the 4th minus u to the 6th du. Okay, so then I can just add 1, divide, u to the 5th over 5 minus u to the 7th over 7. Okie dokie, and then I just need to plug back in for x's, so this would be negative cosine to the 5th over 5 plus cosine to the 7th, don't forget your x's, plus c. Alright, next problem. So this one, I have polynomial over polynomial. While technically I could try to do a u sub here if I got really lucky and the derivative of the bottom was in the top, up to a multiple of a constant. That's not the scenario with this one, so I have to do partial fractions. So step one is to factor the bottom. Okay, this factors into a positive 4 and a negative 3. So my ultimate goal is to be able to rewrite this as a over x plus 4 plus the integral of b over x minus 3. Ultimate goal. So those are much easier for me to do. Alright, but the idea is a times x minus 3 plus b times x plus 4. That needs to sum up to be the top of my current fraction. So we saw this trick in class. If I let x equals 3, then this becomes 0 plus b times 7 equals 15 minus 1. That gives me 7b equals 14, and b is 2. Okay, that's helpful. So then we do the same thing except for we let x equal negative 4. That will give me a times negative 7 plus 0 equals negative 21. I solve that. A will be 3. So then my original integral is equal to 3 over x plus 4 dx plus the integral 2 over x minus 3 dx. I can move the constants out, which is perfectly fine to do, so let's do that. That's the same thing as 3 integral 1 over x plus 4 dx plus 2 integral 1 over x minus 3 dx. And then hopefully I should recognize both of these as natural log. Now you could do a u sub here. You could u x plus 4 in the first integral and u x minus 3. But remember, this is just a shift of 1 over x. It's not changing our antiderivative except for shifting it. There was no stretching, no compacting, because there's no number being multiplied to the x. So then the antiderivative here will just be 3 natural log x plus 4 plus 2 natural log x minus 3 plus c. So if you can't see that, that's okay. Do 2 quick u subs to get yourself there. Alright, next problem. So I look at this problem and I should immediately say, I haven't been asked any problems yet with improper integrals, and I should always just be checking to make sure my bounds make sense for the problem. And make sense means I have to make sure that when I think about plugging in my bounds, my function's actually defined there. And we can quickly see that that is not true for 1/2, as 2 times 1/2 minus 1 is 0, and I cannot have 0 in the bottom of this fraction. So then I need to do a limit. So step 1 would be set the limit up. Let's let t go to 1/2 from the right. The integral from t to 2 of 1 over 2x minus 1. Okay, so now I've set it up, I can do the antiderivative. And again, this is one you can do a u sub, u equals 2x minus 1. But if you do that u sub, you'll see that just this 1/2 pops out in front, and you end up with the natural log of 2x minus 1 t to 2. So go through that little u sub if you can't see it. But remember, we talked about rules for this when you're just multiplying the variable, in this case x, by a number. How that you can kind of quickly see. This is a plus, not a t. Oops. Okay. So we plug in limit as t goes to 1/2 from the right. Now you can take the 1/2 out. I didn't leave myself very much room, so I'll do that in a second. Natural log of 2 times 2 is 4 minus 1 is 3, minus natural log of 2t minus 1. Okay, so remember the limit of just a constant, well, that's just a constant, so this is now equal to 1/2 natural log of 3 minus 1/2 limit t goes to 1/2 from the right of natural log 2t minus 1. So we're just going to evaluate this limit now. So the way that I do these is I just think about, okay, what happens if I was to plug t in, getting closer and closer to the value 1/2 this time, and then I look inside and then kind of just work backwards. So for example, 2t minus 1 will go towards 0 as t goes to 1/2 from the right. Okay, so when I plug in 1/2, I got 0. We saw that above. So as I approach 1/2, I should be approaching 0. Well, natural log, right? Natural log of any variable, x here we can use, will go to negative infinity as x goes to 0. So what I'm saying is the inside goes to 0, so then natural log of something that goes to 0, well, that goes to negative infinity. And if you don't remember that, well, then just graph it. Here's natural log. As my input goes towards 0, my function starts to go down towards negative infinity. So then this limit altogether will approach positive infinity because of the extra negative sign, but that's not a very big deal. The real point here is that this limit doesn't exist, goes off to infinity, and so the entire integral diverges. Alright, next one. So here I gave you an improper with just infinity as a limit, so immediately we need to change to, and let's not use x, let's use b. So we got to change to a limit now. But this antiderivative is not too bad. We do the antiderivative, which will be e to the negative 2t over negative 2. Again, you could do a little u sub here if you want to, if you can't quite see it, and that's perfectly fine. So do that u sub, but you'll get where I got. So I'm going to take out a constant. I'm going to plug in the bounds. Okay. So then again, the constant's just a constant, so this is really the same thing as negative 1/2 limit b goes to infinity of e to the negative 2b. Then if I distribute over, that'll be plus this goes to 1/1/2. So now I'm just, what's this? And again, just graph it. Remember though, I was asked this before, and this is a good question. When you're at this point, you want to graph this entire thing here, and then just let this limit notation piece tell you where to look. So remember, I'm going to graph e to the negative 2b, which looks something like this. Shoots up off that way, okay. And then I'm going to say, okay, this is the b-axis. I'm going to let b go to infinity, which means I turn my head to the right and look this way. Well, I can see that the function is getting smaller, 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 closer and closer to 0. So that means that piece must go to 0. So that's equal to 0 plus 1/2. So we converge, and we converge to 1/2. All right, last problem. So this problem is back in 5.4. I'm defining a function g of x by integrating this other function f of t from negative 6 to x. Okay, so remember, this is our accumulation of area. That's our idea here. All right, so then my question is, for a, just give me the values. So g of negative 6, and you didn't have to write this out each time, but I'm going to do it at least for the first two so you can get the idea of what I'm saying here. Negative 6 to negative 6 f of t dt. So this is the integral from the same number to the same number. No area has been accumulated, 0. So that's me up right here. I haven't done any area yet. So g of -4. So that would be the integral from -6 to -4 of my function. So now I'm asking, okay, how much area have I accumulated here? All right. Well, so at this point, if I just count, this is 2, this height is 4, so that's a rectangle, so that would be 8. All right, g of -2 then is the integral from -6 to -2. So now for this one, we could change the color up here. I want to go all the way out here. So that's now all of this. So what I need to do then is I need to take the area I already had, which is 8, and I have to add to it this new rectangle. But that's again just a 2 by 4. 2 again by 4 again. Okay, so then that's plus 8 is 16. So I'm just going to keep going. So then g of 0 would be now, get rid of that so we have some space. I have now accumulated 16 units of area, and I'm now going to try to accumulate this next piece, which is a square here. Okay, it's a 2 by 2, so there's 4 area there, and then this is half of that, so there's 2 area, so plus 6, that's equal to 22. G of 2, I'm now picking up this triangle, so that's 22 plus 2 is 24. G of 4, I am now taking away, so I've got this 1 by 1 square, and then I've got a little triangle with half that area, so I'm doing 24, but because it's below the axis, I'm subtracting away 1.5, which is equal to 22.5. All right, so B, where does G have a minimum and a maximum? So first of all, if you answered multiple answers, which there are depending on how you read this, but if I ask this, I want the absolute min and maximum, not any locals. So I didn't take off points if you gave me locals as well, but just in the future, the wording on this is supposed to mean absolutes. So let's figure this out. Remember, G as a function is going to have minimums or max at the endpoints or at any critical points. So that means we just need to check x is -6, 4, and then critical points are where the derivative, which is this blue line, are 0. So that is right here. Okay, that's where g prime is 0. Okay, so then what I can do is I can just look at my table actually. So at -6, this is g is 0. Okay, at 4 I'm at 22.5, and at 2 I'm at 24. So just from reading off of this, we've got a min and we've got a max, and then this one here in the middle is a local min. So then I have a min at x equals -6, max at x equals 2. Okay. Now, where are the intervals of concavity? So then remember, concavity for g, so here's g of x, the concavity is the second derivative. But remember the way this is set up. G prime of x is just f of x with this setup. So then g double prime, the function that will tell me about concavity for g, is really the derivative of f. So if I go back here, I'm looking at the derivative of this blue line to tell me about concavity. So I will be concave up when my second derivative is positive, or my first derivative is increasing. I look quickly at my graph, I'm never increasing. Never. This blue line is never increasing. I'm concave down when my blue line is decreasing. That happens from -2 to 3. And there you go. Alright, so those are the solutions to that exam. Again, I'll post both exam solutions, but this will be the only video I have for it. So look this over, fill in the gaps. You'll see when I'm doing these that I'm very quickly doing the derivatives, the antiderivatives of the kind of Calc 1 versions of these things. So, you know, for example, with this integration by parts, I set up this u, this dv, and I just, boom, that's the derivative, that's the antiderivative. So if that's what you really need to practice, then that's what you have to practice. So go ahead, look this over, and please come ask me questions if you have them, and I'll see you later.